Okay, can you please tell me about yourself?
Yeah, I have around 3.4 years of experience in software development, and I began my career at Verizon where I worked mostly on Java and React in that, and I contributed to multiple enterprise scale applications. And later on, I transitioned into projects within the retail domain, so where I expanded my all of the experience and expertise to working with Docker, cloud platforms, and smart IO integrations. And in addition to my development work, I have been taken the leadership responsibilities also. So, for example, in a uh, project, I led my team for the I led the team with the members of four, and I provided the mentoring also. And I also conducted the code reviews, and I also checked the best practices in coding and designing. So my career so far has like I have worked on the hands-on experience on development skills as well as experience in collaboration monitoring and delivering solution in kind of fast-paced environments. So this is what is all about myself.
Okay, so what kind of mentoring you have provided to other developers?
Yeah, so mentoring in the sense I have helped the junior developers who usually join like freshers. I helped them to understand the design patterns while they code and whatever the coding best practices are there. And I used to review their code and how to use also various tools like Git, Docker, and other services. And also um, I used to do the code review, so I ensure the code quality and maintainability, and also while they are writing the test cases, so it should be code coverage should be high, like more than 90% always. So how those things can be achieved and how they can improve their code quality, so in those things I helped them. So yeah, those kind of mentoring I have like given.
Okay, so can you tell me what kind of design patterns you have used and you guided your juniors to do what they did and you asked them to do in different way and how did they improve?
Yeah, sure. So like one of the most common design pattern I have applied is singleton. So especially when working with services like logging and configuration management. So in one of the project, one of the junior developer implemented a configuration reader by creating a new object every time it was needed. So this basically led to multiple instances of the same configuration class being created across the application, and this caused the inconsistent values and unnecessary memory usage. I was supposed to like I needed to ensure that our configuration value were consistent and the implementation was more efficient. So I explained the singleton pattern to the developer, and I showed them like instead of creating the new objects repeatedly, we should have a single shared instance for configuration. So I walked them through the refactoring of their code using lazy initialization to create the object only once and reuse it throughout the application. So after doing this, this change improved performance and it reduced the memory overhead, and most importantly it gave the developer a clear understanding of why and when to use singleton. Yeah, so after that they started applying these kind of patterns later in their codes. So yeah, this is one of the examples I followed earlier.
Okay, okay, good. Okay, any other design pattern you are aware of?
Yeah, I have also used like factory design pattern, then um, uh, observer pattern, builder design pattern. So these are the design patterns also I have used.
Okay, can you tell me why we use builder design pattern?
Yeah, builder design pattern is a creational design pattern and it helps in constructing complex objects step by step, and it separates the construction of an object from its representation. So this allows the same construction process to create a different representation. So for example, suppose we have any employee classes there, and we want only to set the specific properties of it. We don't want to write the uh, whole constructor. Like instead of passing the huge constructor with many parameters, builder lets us to set properties like gradually, so we don't have to set all the parameters in the constructor. Okay, and then uh, also used often to create immutable objects where fields are set only once during object creation, and also the readability is also becomes much better. It improves the uh, readability using the API kind of a structure. Like we can just say set x dot set y dot build kind of. Suppose x and y are the properties. Yeah, so this is what is about the builder design pattern.
But when exactly we should go for this? Any specific scenario can you tell me?
Yeah, scenario means let's say whenever an object has too many optional parameters, suppose, and all the parameters are not supposed to be set every time. In that case, we can use. Also, when constructor or static factories method become hard to read and maintain because of long parameter list. Okay, and when the same construction process needs to create different representation of an object, then we should use this builder design pattern. So yeah.
Okay, so which Java version have you used?
Yeah, mostly I have used Java 8, and recently we have also started working on Java 17.
Okay, and what about the Spring Boot version?
Yeah, I have worked on Spring Boot 2.x.
So, are you aware about the compatibility of Spring Boot with Java versions?
Yeah, so Spring Boot like two version supports with Java 8, and if we have Spring Boot 3 or higher version, then it requires Java 17 or higher version.
Okay, can you tell me the role of constructor in object creation?
Yeah, a constructor we can say is a special method in a class that runs automatically when we create an object. So its main role is to set up the initial state of the object, like assigning the values to variables or preparing resources the object will use. So unlike normal methods, we don't have to call it explicitly constructors. So it executes as soon as we use the new keyword and make the an object. Okay. So yeah, so immediately after that the constructor is called. And constructor are important because they make sure every object starts in a valid ready to use state. So without them we have to manually call extra method after creating an object, which can lead to mistake or like incomplete initialization. So we can also override constructors. So uh, we can provide multiple version of different parameters. Like suppose we can pass one parameter in one constructor and maybe two parameters in different constructor, so the object can be created in different ways depending on the information whatever we have available. So these are the ways we can do the constructor calls. And yeah, so this is how uh, I mean, this is what is the role of a constructor in an object creation.
Okay, can we inherit the constructor?
No, no, we cannot do that. So in Java, we cannot do that. So each class basically defines its own constructor. However, a child class can call the parent class constructor using the super keyword. So this basically allows reuse of initialization logic, but the constructor itself is not directly inherited. So yeah.
Okay, so can you tell me if the constructor can be abstract, static, or final? Okay, and you explain each scenario like why it can be abstract, static, or final, or why it cannot be abstract, static, or final.
Abstract method means the subclass must override it. Okay, but constructors are never inherited. So of course, so making them abstract does not make any sense. So that is what is about abstract. And a static means a static method belongs to a class, but constructors are used to create instances of the class. So if a constructor were static, it could not initialize object specific data. Okay. So now coming to final. So a final method cannot be overridden. So since constructor are not inherited or in overridden, so making them final is like kind of unnecessary. So in very short, constructors are unique to a class and only responsible for object initialization. So abstract, static, or final does not apply to them.
Okay, how about if you can instantiate an abstract class?
Instantiate, no, we cannot directly create an instance of an abstract class. So, however, we can create a constructor within an abstract class, so which can be called from its subclasses. So, we can also have a reference of the abstract class type point to an object of its subclasses. But yeah, we cannot directly create an instance of an abstract class.
Okay. Okay, so can you use a class without creating its object?
Class without its object, yeah, we can do that. So it is possible by using static methods or static variables. So for example, we have a math class, right? So math dot square root, if you want to do so, is math dot sqrt method we have. So directly on the math class, we can do that without creating an object of it. So similarly, we have like other classes also, so it can be done. Yes.
Okay. Okay, what is the difference between is a and has a relationship?
Yeah, each relationship is related to inheritance. So, for example, if a dog is there, an animal is there, so dog is an animal, we say. And a has a relationship is related to composition. So, where one class contains another object of another classes. So, like a car has an engine, so that comes under the has a relationship.
Okay, can you tell me if a class can be final and abstract at the same time?
Final and abstract. No. So a class cannot be both final and abstract in Java. So an abstract class is meant to be extended so that its abstract methods can be implemented by child classes. So on the other hand, a final class cannot be extended at all. So this creates a direct contradiction. So if a class is abstract, it requires inheritance, but if it is final, it blocks inheritance. So in other words, making a class both abstract and final would mean that, I mean, you must extend me, but you cannot extend me. So this is something like that. So that is logically impossible. So that's why the Java compiler does not allow it. So yeah.
Okay, so can you tell me why would you declare a class as final? So what advantages does it provide?
Yeah, we declare a class as final when we want to prevent inheritance. So this ensures the class's behavior cannot be changed by extending it. So there are many advantages, like for security purpose, like it prevents someone from overriding methods and introducing unwanted or insecure behavior. So for example, we have a string, so that is final in Java to keep it immutable and secure. So that is a very good example. And also for simplicity and performance, so simplicity means final classes are easier to design because no subclasses can alter their functionality and performance. In some cases, the JVM can optimize calls to final classes and methods since it knows they won't be overridden. So performance will also be like better. So yeah, so this is the reason why we declare the any class as final.
Okay, so let's suppose you have a base class that provides a common workflow or algorithm. Okay, so all subclasses should follow the same workflow, but some may need to add or customize certain steps. So, how would you design this scenario?
Yeah, so in this case, I would use a template method design pattern. So the idea is to define the skeleton of the algorithm in the superclass as a template method. So this method outlines the main step, and while some steps have default implementations, so others can be defined as abstract or hook methods. Okay, so the subclasses then override only the specific step they need to customize without changing the overall workflow. So this ensures consistency in the process across all subclasses while still allowing flexibility wherever needed. So for example, in a data processing pipeline, the superclass might define steps like fetch data, process data, or save results like that. So different subclasses could customize the process data step while still following the same fetch and save steps defined in the superclass. Okay, so yeah, so this pattern basically helps achieve a balance between code reusability, flexibility, and enforcing a standard process. So yeah.
Okay, so can you tell me how does method overriding work at runtime? And can you override a static or private method?
Okay, so method overriding in Java works through runtime polymorphism. So when we call an overridden method using the parent class reference, then the JVM checks the actual object type at runtime and decides which method to be executed. So this is why overriding is also called dynamic method dispatch. So for example, if a parent reference points to a child object and both have the same method, then the child's version will be run, not the parent's one. So we cannot override the static methods also. And then coming to a static one, so we cannot override the static method because the static method belongs to the class itself, not to the individual objects. So similarly, private methods cannot be overridden since they are not inherited by subclasses. So they are only accessible inside the class where they are defined. So in very short, overriding lets subclasses provide their own version of the method, but it only works with the non-static, non-private, and inherited methods. So yeah.
Okay, so let's say if you have a parent reference point to a child object, okay, so can you tell me which method will be called?
A parent reference point to a child object.
Yes.
Yeah, so if we have a parent reference point to a child object, then the child's method is called at runtime. So for example, let's say we have an animal class and it has a sound method, and again we have a dop class that extends animal, and this also is overriding the sound method, and it is, I mean, something different thing implementing here. And now let's say whenever we say animal a equal to new dog, so here the parent is the reference and child is the object, and now the reference point is parent, and when we say that a dot sound, so in that case, it will be the I mean the child class object method will be called. So yeah.
Okay, let's say if you are designing a notification system, okay, and suppose it supports email, SMS, and push notifications. So, can you explain me how would you apply polymorphism here?
Yeah, in this case, I would start by creating an interface or abstract class, and we can give some name to it like a kind of notification service. So, which makes a method like send notification, and then I would create a separate concrete class like email notification, SMS notification, and push notification, whatever you told. So each implementing this interface and providing its own way of sending notifications. So for example, the email notification class would send emails, SMS will send text message, and push notification will handle the all the push alerts. So by using polymorphism, I can write the client code that works with the notification service type without worrying about the actual implementation. And at runtime, the correct notification type will be used based on the object created. So yeah, so this way we can create it.
Okay, so tell me one thing. When you go for to use if else condition and when you use switch case.
Okay, so if else we can use whenever we are using the complex conditions, there are maybe some logics are there, and like multiple variables or logical operators we are using, maybe let's say age is greater than something and some income is less than this, something like that. So those kind of logics are there. Then we can mostly go for the if else condition, and we can go for switch when we are comparing one single variable against the multiple constant values. Like for example, like let's say if we are checking it like days of a week variable for Monday, Tuesday, Wednesday, like that. So in this case, switch will be more cleaner and easier to read also, like instead of having multiple if else. So this is the one scenario like when we can go for the switch or if else.
Okay, so in a multi-threaded application, multiple threads need to read and update a shared setting configuration object, right? So how would you design it to maintain data consistency and still keep the object properly encapsulated?
Yeah, I would design the configuration object so that its internal state is not directly exposed to outside classes. Instead, I would provide well-defined getter and setter methods to control access. So to make it thread safe, I could use synchronized methods or blocks. And also I can use concurrent data structure like concurrent hash map is there. If the configuration is stored as key value pairs for immutable configurations, I can use the immutable object patterns. So yeah, so this way the object remains encapsulated and while still being safe to use in a multi-thread system. So these things we can use.
Okay, so in Java 8, can you tell me the points? How do you write the better code in the Java 8?
Yeah, we there are many things which we can do. Uh, like we can use the lambda expressions instead of using the older way of doing the things, and then uh, for null pointers we can use optional, and also the datetime APIs we can use the new one instead of using the older datetime API, and we can also use the solid principles. And we can also for testing we can ensure that the test coverage is proper and it is like more than 90% or something like that. Okay, and so yeah, so and we can use streams instead of older way of iterating the things. So those things we can use, yeah.
Okay, can you tell me the difference between for each and for each ordered?
Yeah, for each is when using a parallel stream, elements may be processed in any order, so there is no guarantee. And for each ordered means like always respects the encountered order and order of the elements in the source. So whatever the order it is there in the originally, so in that order only it will be shown. So for example, let's say we have a arrays.as list and we have a b c d e like that. And whenever suppose if we are using parallel stream here and we are saying a for each, so in that case it will can be any order. Okay, so it in any order it will be displaying, but whenever we say let's say names dot parallel stream dot for each ordered, so in that case it will appear in the ordered fashion like how it was earlier, like a b c d in that for, order only it will appear. So yeah, so that is the difference between these two.
Okay, can you tell me the difference between pass by value and pass by reference?
Yeah, Java is basically passed by value. So when a primitive type is passed to a method, so its value is copied. And when an object is passed, the reference or the address to the object is passed by value. So basically this means that the changes made to the object's state within the method will persist, but if the reference itself is reassigned to a new object, the original reference outside the method remains like kind of unchanged.
Okay. Okay, so can you now tell me a small code snippet? How would you sort a list using the stream in Java 8?
Okay, we want to sort it, then suppose we have a list, then list dot stream dot sorted we can directly use, and we can pass a and b as a parameter in the lambda expression, and then a dot compared to b we can use, and then for each, and then we can just print it.
Okay, good. Okay, can you tell me some important annotations you have used in Spring Boot?
So add the rate of spring boot application, add the rate of rest controller, add the rate of service repository component, then bean auto wired configuration. So yeah, so these are the annotations I have worked with.
So, how can we create a Spring Boot project in the initial steps?
Yeah, we can create the Spring Boot project using the Spring initializer like starts.spring.io, or we can also use directly ID maybe through Eclipse or IntelliJ, whatever ID we are using. So we can typically define the project metadata group artifact and we can choose the build tool, whatever Maven Gradle we are using, and then we can select the Java version and we can add the necessary starter dependencies like Spring Boot starter web security test. So all those things we can add as per our requirement, and also like whatever server if we want to add like pre-configured Tomcat, so those things also can be added. So that is how we start, I mean, the initial project for the Spring Boot project.
Okay, so what is this starter dependencies?
Yeah, starter dependencies are a set of convenient dependency descriptors in Spring Boot. So they bundle common dependencies together to simplify configuration. For example, a Spring Boot a starter web, we have a Spring Boot starter security, we have. So this web, for example, that includes all the dependencies needed for building a web application. So we have like Spring MVC and like maybe embedded Tomcat server. So these things will be auto included as soon as we include this Spring Boot starter web. So yeah, so this is what is the starter dependencies.
Okay, can you tell me what are the alternatives to AutoWire in our Spring Boot application?
Yeah, the main alternative are constructor injection and setter injection. So constructor injection is generally preferred for mandatory dependencies as it ensures the object is in a valid state upon creation, and it improves the testability. So yeah, so these are the alternatives of this.
Okay, so how can you create the REST controller? Can you explain?
Yeah, we can create the REST controller using the annotation at the rate of REST controller, so that we can put inside the class, and we can define the methods that handle HTTP request like get mapping, post mapping, put mapping, and all. So initially on top of the class, we will be having the data REST controller, and also the top level path if we want to give. So that we can give like a data request mapping we can give on top of that class. And then again, let's say we have a user controller, so the class name will be there, that user controller, and inside that we can have the CRUD operations, like we will be having, let's say, get mapping will be there, post mapping, put mapping, delete mapping will be there. In the get mapping again, we can give the path variables and all, and suppose if you want to say the get by id, so in the path variable that id we can give, and we can further from here we can make the calls to the service layer, and again from service layer we can make the calls to the repository layer and to the database. So that is how the whole flow goes. And again for post mapping also, we can accept the request in the form of add that of request body. So whole object of, let's say, user is there, so whole object of user we can receive, and we can further process the data. And put mapping is also there, so in this also again the same similar kind of stuffs we can do. So yeah, and in delete mapping is also there. So this is what is the typical CRUD operation, and we do for any object.
Okay, okay, good. Okay, can you tell me how do you handle exceptions in REST controller?
Yeah, we can use add rate of exception handler inside the controller, and we can also use global add rate of controller advice. So suppose if you're using exception handler, so we can define the method inside our controller and annotate it with exception handler to handle a specific exception. So basically this gives the control when we want to handle errors for just one controller. But if we have the scenario like we want to handle the exception globally, so then we can go for the controller advice. So this is kind of a centralized approach where we create a separate class annotated with add controller advice and define exception handler method inside it. So this way all controllers in our application can share the same exception handling logic, so that makes the code more cleaner and easier to maintain. Yeah, so additionally, apart from that, we can return custom HTTP status code and error codes using the response entity. So the client get the meaningful response instead of like raw messages. So many projects also define a custom error and response object. So we can also give the additional fields like timestamp, status, error, message, even path also we can give to make the API error response consistent and user friendly. So yeah,
So, can you tell me what are the important components of a Spring Boot based microservices architecture?
yeah. So key components like we have API gateway is there, then service discovery is there, configuration server is there, and then all individual microservices are there. So these are the key components. So API gateway is basically like it is a single entry point we can say for all the client request whichever comes. and that routes them to the appropriate microservices. So that is what is API gateway. Apart from that, here there can be multiple things also. So apart from that, it can also be used for authentication and authorization, and rate limiting and load balancing, caching, and centralized logging. So many things can be done here. And then service discovery is a mechanism for services to find and communicate with each other. And then a centralized configuration server is a centralized place to manage external configuration for all the services. And then we have the standalone different individual microservices. So each service is responsible for a separate specific business like requirement. So like each and different developer is like not usually handed over to the specific microservice, and they can uh, work on this work on that solely. And yeah.
Okay, so suppose you need to share the authentication state across multiple microservices. So how would you approach it?
Yeah, so for that, this can be achieved by using a centralized authentication services like an identity provider. So that issues the token like JWT, and the API gateway would validate the token on incoming request, and then the token can then be securely passed to the downstream services. So this can be used to get the user's authentication authorization state. So yeah.
Okay, can you tell me if the Spring Boot provides any default cache?
Default case, yeah, Spring Boot provides a caching abstraction layer that works with annotation like at the rate of cacheable. So if we don't configure any external cache like Redis or ES cache, then Spring Boot will use a default in-memory cache. So that is actually done backed by a concurrent hash map, and this is useful for development and a small scale use. But for production, we typically configure the external caching providers like Redis and all. So yeah.
Okay, what is Spring Data JPA and how does it simplify DOA layer development?
Yeah, Spring Data JPA is a part of a Spring Data project that makes working with databases much easier. So normally when we build a DO layer, data access object layer, basically it means we write a lot of boilerplate codes for CRUD operations. With Spring Data JPA, we just define an interfaces with like that extends JPA repository or CRUD repository, and we can automatically get methods like save, find by ID, delete by ID, and all, and pagination, sorting, and all supports also we get. And it also provides query methods like find by name, and Spring generates queries based on the method names. So this reduces the boilerplate codes and it speeds up the development.
Okay, so as you said, we have Spring Data JPA that provides like find by ID, delete by ID, and all like derived queries, right? Now, what if you need a query that does not fit into that Spring Data derived query methods? So, what will you do for that?